Hi students, welcome to Veteach app. So first of all, we discuss about the syllabus. We have 5 modules are there. In module 1, what things are there, which is important, also very important for us. In module 1, the basic concepts, right students? So basics are important. So what are the basic things in this module 1 is sources. So in module 1, the basic concepts like the voltage sources, current source, parameters, source transformation, network reduction, star delta transformation, loop and node analysis with linearly dependent and independent sources of AC and as well as DC networks. Students, the basic parameters or in daily life we will use this electrical terminology like current, voltage, power. Okay, so loads in our house we use some loads. You don't know that the meaning of load, but daily we are using this one. So these things comes under the basics of electrical engineering, right? Sources, voltage source and current source, and source transformation means transfer from one to other, reduction techniques, reduction techniques. Students, now once upon a time uh, land phone is there. Next we use it only for messaging and as well as calling. But now what happens in a mobile? All things are we are seeing and we are watching. Why? Because it is nothing but what the circuits are reduced and having n number of things that we are using in a mobile. So this is also designed by the science and technology. Okay, so normally total electrical system depend upon basic law is Ohm's law. You know that in 9th class, 10th class, intermediate you learn about the Ohm's law, which gives information about voltage, current, right? So a part of that one more scientist Kirchhoff's law he given, that is loop analysis and as well as nodal analysis, KVL and as well as the KCL, Kirchhoff's voltage law and current law. So big apartments, big industries or hospitals, how the connections are there, okay, how it is working, those are very important. Next, and we have some sources. We have AC source and as well as DC. AC means alternating current and DC is direct current. Most of the case we depend upon AC, alternating current, and some cases we are using direct current. So this module 1 gives information about the basic concepts. If the basics are good students, then coming chapters also very easy for you. So try to give more concentration on the basics. Right? Now, next we go for a module 2. In module 2, we have some theorems, network theorems. Students, have you heard this word circuit and as well as network? Okay. So, circuit, combination of elements, and network is the combination of circuits. So, here in terms of voltage or in terms of current, what happens? We are using one case has a high voltage, another case we are using high current, vice versa. In some case we use some power. So according to our requirement, we have some network theorems. Some scientists have designed some theorems like superposition theorem. In superposition theorem, this theorem exclusive give information about the current source, about the currents. Whereas Milliman's theorem also gives about the power. Thevenin's theorem gives about the voltage. Norton's theorem gives about the current. Maximum power transfer theorem. Already you know the maximum power. So this theorem is giving the maximum power. So each and every theorem has its own application, own advantages and own concepts. Right? These theorems also we are using in our daily lives. So coming to the module 3. In module 3, transient behavior and initial conditions. Student, have you heard this word transient? we have two states are there. We have two states like steady state and as well as a transient state. Students, steady state is nothing but always it is constant with respect of the time period. It never changes. That we are saying as a steady state. Our entire electrical system is a steady state. In transient state, nothing but some change. That state we are saying as a transient state. For example, student, switch is there. Switch we have two conditions, on and as well as the off. Okay, the changing of on to off, off to on with respect of the small change in time, that we are saying as a transient. So transient analysis also very important with respect to of loads like R, L and C. In this module 3, we discuss about the behavior of circuit elements. Switching condition means switching, okay, in terms of initial value and as well as the final value. So combination of RL, RC and RLC. Some cases we use RL load, some cases we use RLC, some cases we use RC. Okay students, so these three loads plays a major role in our daily life. Now, can you give the examples of R, resistive load? Can you give the examples for inductive load? Can you give the examples for capacitive load in our daily life? Right? So our bulb is there. Bulb is a resistive load. Iron box is a resistive load. Our tubelet is there. Tubelet is a choke we have. That is inductive load. A motor is there. A mixie is there. Inductive load. In a tubelet we have a condenser is there. It's a capacitive load. Like that, in our daily life, these three elements normally we will use, but we don't have any idea about that, how it is working, what is the purpose of this one. Okay, in this subject, we will discuss all these things with basics. So this is about the transient behavior and initial condition, module 3. Now coming to the module 4. Module 4, Laplace transformation and applications. Students, it is a new method. Normally, a total system depend upon the time period T. Okay, so time period can be converted into other form in terms of frequency mode. So to change the time period to the frequency mode, we are using this Laplace transformers. Have three different types of signals are there. The behavior of the system we can identify by using this Laplace transformers, right? Solutions of a network, step, ramp and impulse response with waves synthesizers. Synthesize means we are minimizing the waveforms. So this is a Laplace transformation. And last unit, that is module 5th, gives about the two-port network parameters. Two-port. See students, it is expanding the subject here. First we have a basics are there. Next we have some theorems are there. Next we have a transient is there, and next we have some two-port parameters. So two-port parameters gives the unknown values. We have to find the unknown values. Two things we know and two things we have to find from these parameters. That's what we are saying as a two-port parameter. Two-port nothing but we have two input terminals and two output terminals. In terms of dependent values and as well as independent values, from that we have to release the relation and we have to find the unknown values. So we have Z parameter or impedance parameter. Number 2 is Y parameter or admittance parameter. Number 3 is hybrid parameters and transmission parameters. And there's modeling, and they can they have relations between these parameters also. Okay, they can convert, they can exchange from Z to Y, Y to Z, and Z to ABCD, like that, vice versa. We can have relations also. Not only that one, between parameters. So this is the other extension of our subject, two-port networks or two-port parameters. Right. Students, you know this meaning of resonance. In physics, we learn resonance. Series resonance is there, and as well as the parallel resonance is there. So you are very familiar about this resonance. Why? Because physics is very interesting one. So here series is there and parallel is there. You know the resonant frequency, bandwidth, quality factor, selectivity, So such type of things means all signals depends upon this resonance. Our TV signals or communication signals depend upon a resonance with respect of a selectivity, quality factor, and as well as the bandwidth. So this is your module 5, students. So first of all of you uh, read and try to by heart the syllabus. First of all, in unit 1 what things are there, in unit 2 what things are there, in unit 3 what things are there, unit 4 what things are there, and unit 5, so that you have some idea. Yeah, yes, this unit comes under these topics, this unit comes under these topics, so you will have some idea. Okay, students, so try to learn the concepts of each and every module of 1, 2, 3, 4, and 5. Okay, so this is a brief explanation about your syllabus of module 1, 2, 3, 4, and 5. Now we teach, we design, we prepared a model paper. Your coming exams are there na? So network theory, from seeing this syllabus, and we design one model paper. Now I will explain that model paper, the question with respect of some brief explanation about each and every answer. Okay, students, so listen carefully, try to understand the concepts, and write the exams well and good. Okay, now I will go for a model paper. So this is your model paper of network theory. In module 1, so what questions are there? 100 marks question, and 10 questions. In that you have to write any 5 questions. Each question carries 20 marks. Right? Module 1, first question, draw the symbols of dependent and independent sources. Students, we have two sources. One is voltage source and current source. So again these sources are divided into dependent and as well as the independent. Now students, you are independent or dependent? Yes, you are depending upon your parents, that's what you are dependent sources. So here also some sources are independent and some sources are dependent. So independent sources used in electrical system and dependent sources used in electronics. And how to identify these symbols, sources with symbols? Okay, here minus and plus, this is voltage source, minus and plus, it is rise in voltage. If it is plus and minus, it is fall in voltage, or we can say minus V of S. And the arrow mark indicates about the current source, I of S. I of S. Voltage source and current source, fall in voltage, rise in voltage, fall in current, rise in current. And these two sources are DC source, DC sources. DC sources means direct current sources. We have AC source also there, alternating current sources. So how to identify these alternating sources means same minus and plus, but here Vs of t. With respect to time period, that source we are saying as a AC source, AC alternating current source, or a arrow mark is there, that is I of S of t, that is AC source. Without time period DC, which time period is AC, voltage source and current source. Again these are divided into two types, dependent and independent. Students, you are dependent or independent? So you are dependent and your parents are independent, you right? First of all, dependent sources, I will explain about the dependent sources. The symbol of dependent sources is a diamond shape, minus and plus V of t. Okay, a diamond shape source are nothing but what are dependent sources, like you, okay, I of S. These type of sources used in electronics, whereas independent sources, that is your parents, independent sources are with circles. with circles. Diamond shape are dependent, circle shapes are independent. Like that you have to understood these sources. Okay. So this is your first answer, types of sources and as well as the types of. Next one, define source transformation and convert voltage to current source. Source transformation. Students, transfer means what? Moving from one place to other place. Moving to one place to other place. So here also the current source can be converted into a voltage source and voltage source can be converted into a current source, vice versa according to our requirement. For this, the basic law is important here. For this, the basic law important. That law is nothing but Ohm's law. And total entire electrical system is depend upon what here? Ohm's law. Ohm's law. What Ohm's law we have? V is equal to I into R. Here voltage source V, Vs, that is current into R. I want current source, Is is equal to V by R. Two formulas by using Ohm's law. So voltage source, here combination of resistance and current. Here current source, the voltage with respect to the resistance. So like that, we can convert the voltage source to the current source and current source to the voltage source. How? The equivalent circuit diagram of a voltage source is normally voltage source in series with the resistance. This is internal resistance Rs, this is RL and this is IL. So voltage source in series with the internal resistance across the load resistance. So this is the voltage source equivalent circuit diagram. Now I want to find the current here. Then I is equal to what we can get here? Vs by Rs. Vs by Rs. What you are getting here? Current. Unit ampere. Unit ampere. The same way, current source. Current source. How to draw this current source equivalent circuit diagram? Yes. Is, this is Rs, RL and IL. Current source in parallel with the resistance, internal resistance across the load resistance. So voltage in series, current in parallel. These things you have to understood. And very important thing here that the Rs value here Rs is there na, here Rs, this value is never changed, it is always same. It may be a voltage source or it may be a current source, but the internal resistance never be changed. So like that, the source transformation we can convert from one source to the, okay. So by using which law? Ohm's law. Third one, develop mesh equations for the circuit shown in figure. Develop mesh equation, mesh analysis, or other name is loop analysis. Okay, Kirchhoff's given this laws, that is KVL and as well as KCL. Exclusive to find voltage, exclusive to find the current. We are using this losses. So in that mesh analysis or loop analysis. Loop is a closed path. Students, in a closed path what happens? Current will flow or voltage will flow? Yeah, current will flow in a closed path. Okay. So here also by using mesh analysis you have to find the unknown currents. Unknown currents. See here. Here a network is given. Network given. Right. So a voltage source is there. Other voltage source is there. Other voltage source is there. Three voltage sources are there. And how many loops are there? I1, I2 and I3. Three loops are there. So how many currents that we can find here? I1, I2, I3. Resistance are there, voltage are there. You know voltage, you know resistance. Can't you find the current here? Yes. By using which law? Ohm's law. Current is equal to V by R. Current is equal to V by R. Right? Loop analysis or mesh analysis. Right? Now see here. This is loop 1. I am taking loop 1. Okay. Draw in a clockwise direction. Clockwise direction. First one. Right. Here minus and plus is there. So minus 100 volts. First relation is minus 100 volts plus 50 into, here I1 is flowing across 50 and here I3 also flowing here. So what we can get here? I1 minus I3 plus, like this, here 100 ohms are there, 100 ohms. So I1 and as well as the I2, two currents are flowing across 100 resistance. So 100 into I1 minus I2. Here again what we have? Plus 40 into I1 is equal to 0. Students, this is the way that you have to write the loop equations or mesh equations. It's a closed path, current is flowing across each and every branch, and you have to initialize this one and you have to release these relations. Like this is loop 1, this is equation for loop 1. Now coming to the loop 2, same. Okay, loop 2, what happens here? Okay, starting from this one, 50 ohms. 50 ohms is in between I2 and as well as I3. Yes or no? Right. So 50 into I2 minus I3. I2 minus I3. Okay, come like this. Right here, how much here? Minus 200 volts. Minus 200 volts. Okay, here 30 is there. Here 30 plus 30 into I2. Moving up plus 100 into I2 minus I1 is equal to 0. Step by step, what are the branches are there, which current is flowing across this one, which is in between the loops, that you have to mention here. You have to mention. So this is loop equation 2 and equals to 0. So you will get the relations in terms of I1, I2 and I3. Three loops will get three different three different relations. So you go for a 3 by 3 matrices and you have to find the unknown currents, that is I1, I2 and I3. So this is the basic concept of mesh analysis, right? Closed path, current is flowing across each and every branch, write the relations, equalize them and find the unknown currents. You know current, you know resistance, can't you find the voltage? Yes. There is nothing but what a voltage drop across each and every branch. Okay, such type of problems are very, very important, students. Practice as number of problems. In module 1 and other questions like determine the source current IS with a DC voltage source of 6 volts is connected between A and B using star delta transformation. Right. One more method is there. Ohm's law first of all. Next, Kirchhoff's law, KVL, KCL. Next, we have series connection, parallel connection. If the network is complicated, again one more method is there, that is star delta method. Okay, the network can be converted into star and as well as the delta. Okay, so here by using the star delta method, we have to find the current of source current across each and every resistance. How? Let's see. Students, see here, see this network. A, B, C, D are 4 points are there, 4 nodes are there. Okay, this is a midpoint N, right? And see, all the resistance are same. All the resistance are same. So there is no problem for us. Okay. Now see here, from B, C, N and C, how it is? It is like this. So it is nothing but what a delta connection. It is a delta connection, or if it is there, this is a star connection. So according to our convenient, so it is delta 1, this is delta 2, this is delta 3 and this is also delta 4. Okay, students, but no, don't confuse like that. Okay, just you take these only these two delta values, this one, this one, this one, this one, this one, this one, you keep this one, right? Delta values converting into a star. some problems are there, some formulas are there. Okay, substitute that formulas and convert this delta to a star, right? So product of resistance by sum of the resistance. To find the star value, what is the formula? Product by sum of the resistance. So then this delta will becomes what here? Star connection. If star is there, adding of two resistance makes what? A series. Okay, if series is there, then we can add very easily. You know voltage, you know resistance. Can't you find the current? Yes, we can find the current. Why? Because all the resistance are same values here. So delta to be converted into a star. Again, if we add star, right? Then you can add the resistance. Then you will get a total resistance RT. You know voltage 6 volts. Then you can find the current source, that is voltage source by what? R total. So this is your star delta transformation. Derivation is important, and as well as to do some problems also important here. Next one, find the node analysis technique. Previous we discussed mesh analysis. This is node analysis. Determine the node voltage and branch current across each resistor. Node voltage and branch currents. Okay, mesh is nothing but a loop analysis. In a closed path, current is flows. Okay, here by using node. What do you mean by node? Node is nothing but joining of 2 points. Joining of 2 points. Joining of 2 points. So this is nothing but what? A node. Okay, how many nodes are there? V1, V2, V3 and V4, V5. How many sources are there? One is current source, other is current source. Okay, two current sources are there. See, it is rise in current. If you come like this, what happens? It is fall in current. It is also important here. So 5 nodes are there by using nodal analysis. Okay, so here what we can find? So current is equal to voltage by resistance. I is equal to V by R. Now students here see at node 1, how many currents are coming here? Here I1, this is I2. Okay, now only two currents are there, I1 and as well as the I2. Those are coming towards the away now. Yes, those are away from the node. Away from the node. So what we get here? I1 plus I2 is equal to 0 at node 1. You have to write like this. Steps are very, very important, students. At node 1, the two currents are away in terms of I1 and as well as the I2. But what do you mean by I1? What do you mean by I2 also important here to release the relations? That is I1 is equal to, what we get here? I1 is equal to V1 by 2 ohms, voltage by resistance. Whereas I2 is equal to what we get here? By, like that, each and every node, node 1, node 2, what currents are coming here? Towards I3 and as well as I5. At node 3, one is coming and one is leaving. At node 4, one is coming and other is leaving. So two are leaving, two are coming here. Two are coming and two are leaving. So this way you have to find the nodal. Across the node you have to find the current. In a loop you have to find the voltage. So these two are very, very important. The derivation and as well as the problems. Compulsory question, students. Now coming to the module 2. First one is basic concepts, right? The module 2 we discuss about the theorems. We have 5 to 6 theorems are there normally, right? Here for the very first question, write the steps to find the Thevenin's theorem with equivalent circuit diagram. Thevenin's theorem. Students, try to understood that whenever the theorems are there, what things that you have to mention there. Okay, so I will explain. So you, right, in a theorem, first of all we have a statement will be there. First one is statement. Okay, next Next, a network he will give, problem will be a network. In network, we have to find a voltage or current, voltage or new current values, not existing one, right? And a new resistance values, and to draw a equivalent circuit diagram, that you have to draw. And last one, you have to find the load current. So this is the step-by-step method that you have to find the theorems. Derivation part are problematic. Okay. So here we're going to do your first question. So now I will discuss about the Thevenin's theorem. Right? Thevenin is a scientist. His name is Thevenin. He proposed a theorem. That theorem we are saying as a Thevenin's theorem. So statement means a big network is there. A big network and n number of sources are there. And it is a bilateral network. It is a bilateral network having n number of sources and having n number of resistance. So what he done across the load resistance? What he done? He replaced all the source into one source, and he replaced all the resistance values into only one resistance across the load resistance. So that equivalent circuit we say as a Thevenin's equivalent circuit diagram. From that we can find the load current. Okay. So what is the procedure to find the, okay students, now for example I am discussing about the Thevenin's theorem. Okay. Now for example, he given one network. I am saying of the steps. Okay. RL, this is R1, this is R2, this is R3, this is voltage source. Okay students, a network given. So in Thevenin's theorem, what things that we have to find means, first is we have to find the VTH, next we have to find the RTH, next we have to draw the equivalent circuit diagram, and fourth one we have to find the load current. Okay students, now step 1, here step 1, remove the load resistance. First one, remove the load resistance. Then what happens here? If you remove this one, this becomes what here? It is open circuit. It is an open circuit. In open circuit, what will be there? You have a voltage, a new voltage, right? Across the resistors also we have same voltage. That voltage, what is saying? Is saying as a Thevenin's voltage. This is first step, right? Next, to find RTH. Step 2, you have to try like this: step 1, step 2. Okay. Step 2, to find RTH. Okay. Short the source. Okay, students. Short the source. Now what happens here? Short. These are resistance are there. Two resistance with respect to open circuit. There is no fault. So here what happens here? Then RTH is equal to R1 into R2 by R1 plus R2. Right? You will get a new RTH value here. New RTH. Right? Voltage we removed, and we remove the load resistance. We find new two things, that is Thevenin voltage and as well as Thevenin's resistance. And third one, to draw the circuit diagram, equivalent circuit diagram. This is VTH, this is RTH, it is RL. Across RL, current is flowing IL. Okay. A big network is minimized to a small network, that is Thevenin's equivalent circuit diagram. So last one, to find load current, IL is equal to VTH by RTH plus RL amps. So this is the steps to find the Thevenin's theorem. statement, circuit network to find the VTH, new voltage and new resistance, equivalent circuit diagram and load current. So this is the, if you follow this, then you will get good marks. Now find the load current from the given circuit by using Thevenin's theorem. Here you have to find the load current. Same steps, 5 steps. Okay. First of all, what to do? Remove this one. Right? Here you have to find the VTH. Here 100 volts is there. Across this one, it will be less than 100 or more than 100. Yes, it is less than 100 only. Less than 100. So you are finding a new voltage. New voltage. Right? So that is nothing but VTH. Next, what you do? Short this one. And you have to find the RTH. Okay. 12 by 7. You will get some resistance value. Next, to draw the equivalent circuit diagram. And what is the load resistance here? 10 ohms. 10 ohms. So then IL is equal to VTH by RTH plus RL. RTH plus RL. This is your required equation or required formula. Right? So first of all, try to understand the concept here. What type of theorem? What we are finding? Then only you can practice some problems. Steps are very, very important here. Okay. Now, right. In the third one, see, state and explain superposition theorem. Okay, students, we have 5 to 6 theorems are there. The first theorem, what we discussed about the Thevenin's theorem. Here, one more theorem is there, superposition theorem. Superposition, position. This theorem discuss about the position of the thing. What that position is means here the theorem gives about the current. Explain about the current. This is not useful for power, only used for only to find the voltage and currents, not for the power. So what is the statement of this superposition theorem also important here, right? Students, have you heard this word bilateral network? Unilateral, bilateral, what it gives, right? Now if I say diode is a unilateral, bidirectional? Yes, it is a unidirectional. But whereas resistance, inductance, capacitance are bidirectional, right? So superposition theorem, position of the system in a network. Okay, now see here, I will give the concept of this theorem. Okay, this is normal network having two voltage sources V1 and as well as the V2, and 3 resistance are there, R1, R2 and as well as the R3. So the junction or a node. So this is I1 and this is I2. Okay, two sources are there. Okay, first one, what a step 1, when two sources are there, V1 and V2 are there, then you will get a total current IT. Total current IT across this R3. Across R3 resistance. What superposition theorem is saying that replace one source. Replace one source and find a current. Find a current. Okay, students. Suppose open circuit R1, R2, R3. Okay, open circuit, there is no effect of this resistance. Open circuit here. So current is flowing across this one, I1. Okay, here I1, we are getting new current is when V1 is there and V2 is open circuit. V2 is open circuit. Okay, here you will find a new current, that is I1 dash. New current is I1 dash. Right? So this is step 1 and this is step 2. Now step 3. Step 3, what happens here? Remove other source. Remove open circuit R1, R2, R3. This is V2. Okay now? Here V2 is there, V1 is open circuited, and you are finding here I1 double dash. I1 double dash means sources are removing and finding a new current. That is nothing but position of the current. Okay, first of all, two sources, total current, removing the source, finding new current I1 dash, and again one more source you are removing, finding other I1 double dash. So here the condition to get a superposition theorem is, that is, I total is equal to I1 dash plus I1 double dash. I total is equal to I1 dash plus I2 dash, then only the theorem is verified. So this is the one more new method, position of the current in terms of sources. Okay, suppose current source is there, you have to short. Voltage source we are removing, but current source is there, then you have to short and you have to find the value. So this is one more theorem exclusively used to find the current and voltage, not for the power. Write the steps to find the Norton's theorem with equivalent circuit diagram. Steps to find the Norton's theorem. Previous the Thevenin's theorem, and this is a Norton's theorem. Thevenin's theorem is used to find the voltage, whereas Norton's theorem is used to find the current. Okay. So what are the different steps also now we will discuss. So what are the different steps to find the Norton's theorem also important here, right? How we find the steps to find the Thevenin's theorem, here also Norton's theorem also some steps are there. What are they? Okay. Normally a network will be there. This is symbolic small network I am taking here. Voltage source, this is RL. Across this one I have to find the load current. Right? Normal network it is. Resistance are there, voltage source is there, and as well as the load resistance is there. So what are the different steps to find the load current, Norton's theorem? So one thing that you have to keep in your mind, Norton's theorem is used to measure only current. So how will you get the current? What you have to do? This load resistance, you should be short or open circuit. In Thevenin's what we done? We done open circuit and you find the new voltage. Here what we are doing? You have to short the load resistance and find the load current. Okay. So short the load resistance, short the load resistance, then it is a short circuit. In short circuit what happens? The current will flow, right? So when current is there, then that current we are saying as a new current, that current is Norton's current, R1, R2, R3 short circuited. How these are? Parallel in series with the resistance. This is voltage source. Okay. So first thing you have to find the Norton's current, right? That is new current. Next, again step 2, short the voltage source, R1, R3, R2. Okay. Here you will get RN, IN, RN. Third step, equivalent circuit diagram. Always the current source is in parallel with the load resistance. Norton's for current, Thevenin's for voltage. Voltage in series with the Thevenin's resistance, Norton's current in parallel with the Norton's resistance. Right? The last thing that we have to find is to find a load current. IL is equal to IN into RN by RN plus RL. Load current. Our main point is to find the load current. So these are some of the steps to find the Norton's Norton's theorem. Norton's theorem. Find the load current across the load resistance 10 ohms by using Norton's theorem. Right? Same thing. Right? Short this one. Short load resistance. Find a new current IN. Right? First thing. Short the voltage source. Find RN. Find RN. This one and this one like this. And draw the equivalent circuit diagram. RL, RN, IN, IL. And last find the load current. Okay. Voltage, Thevenin's theorem. Current, Norton's theorem. Current, superposition theorem. Position of the current is superposition theorem. Okay. So like that, try to practice some problems, students. Here, steps are important here. Only 4 to 5 steps if you by heart, then automatically you can solve the problems very easily. Now, one more. Find the condition for maximum power transfer theorem. Right? Students, here, power transformer theorem is different and maximum power. Power normally. Maximum means what? High value. Okay. For high power value, what is the condition is asking? What is the condition? Okay. This is also one more method is there. One more theorem exclusive using for to find the power. Right. Normally voltage, current and power. Right. These three theorems we are try to learning and get the concepts. Okay. So one thing here, maximum power transfer theorem is 80% is depend upon Thevenin's theorem. What a Thevenin's theorem, students. Okay, same steps. Network given, open the load resistance, find the new voltage VTH, short the source, find the Thevenin's resistance and draw the equivalent circuit diagram. Right? Draw the equivalent circuit diagram. Right here. Now this is the point here. This is VTH, this is RTH and this is RL, this is IL. Okay, students? Right? Now, so this is a variable value. Load resistance here variable. Right? RTH is a fixed value. RTH and RL both are resistance only. Both are resistance. So power transfer is going on good. Okay? From 0 to 1, 2, 3 like that is going on increasing the value of RL. But certain point where suppose it is 5 ohms example 5 ohms. So at 5 ohms these two values are same. RTH and as well as RL value will be same. That condition we are saying as a maximum power transfer theorem. Okay. What condition? Where Ri is equal to RL. The values are same. That is the maximum condition. Maximum power condition. And how the graph is, students, see. Okay. This is power. This is resistance. So increasing at some point it is P maximum. Right. If you want to know the maximum power transfer theorem, 80% is in terms of Thevenin's theorem only. Only condition is Ri is equal to RL. Ri is equal to RL. To find the maximum power, V square by 4 into RL. 4 into RL. V square by 4 into RL is the to find the maximum power value. Okay, three things. One is depend upon the Thevenin's theorem. What is the condition to get the maximum power is Ri is equal to RL. And what is the formula to find the P max is V square by 4 into RL. Your derivation is there. Isn't it? Derivation is there. If we do derivation, we will get this condition and as well as the power. Okay. So 50% of the power we are using, maximum 50% efficiency of the power we are using. In module 3, the questions, fifth question, define time constant for RL and RC series circuit. Time constant. Time constant can be defined as the changing of state from initial to the final. Initial to the final. The fraction of seconds. That time we are saying as a time constant. In transients, we have RL circuit is there and RC circuit is there, and this time constant can be denoted letter tau. For RL circuit, it is the time constant is L by R, and units are seconds. Whereas for RC circuit, the time constant is R into C. Units are seconds. In transients, mainly depend upon initial value, final value in terms of time period. So derive the transient response of RL series resonant circuit. Okay. So RL, transient response. Transient means changing of stage from one to other with respect of the time period. We are saying as a transient response. Okay. Initial, final. T is equal to 0 minus is equal to T is equal to 0 plus. Right. Here we are using two values in terms of resistance and as well as the inductance. Inductance is a storage device, where resistance is a dissipative device. Okay. The order of the system is single order system. It is a single order system. Here, if switch is closed, switch is off, switch is S is equal to half and S is equal to on, two conditions. What is happening in between this in terms of R and L? That is the response of the transient system. Okay. Two things that we have to find from this transient analysis. Okay. So the derivation will be there. So in terms of apply the KVL across this one, you will get a Ri plus L di by dt is equal to V. Okay. So here single order system it is, and you have to find the slope from this one, and applying the initial conditions for this one, and forced value you have to find out, and particular function you have to find from this one. Joining of these two things, then we'll get a response. So switch is moving from one position to the other position. L is a storage device. There is a storage device. Single order equation. So here the system is to be identified by using time constant. Already we discussed the time constant for RL is L by R. So if we derive the relation, we will get a exponential form. Okay, students. So first of all, S is equal to 0 means switch is on, and if a switch is closed, how the current is flowing across R and L, and what is the differential equations, and how to find the time constant. So this is the concept of transient response. Now same RL circuit is there, voltage given, 100 ohms is given, and as well as 1 millihenry is given. What you have to find out here? IN as well as the di by dt. If we derivate again, we will get this d square I by dt square. Okay. So the next one is to do some problem, to solve one problem. Same transient response of RL series circuit. He given R value and as well as L value in terms of voltage. To find here current, rate of change of current, and increment of current. Okay. So from derivations we can directly substitute the values and you can find the value. Or what are the initial and final conditions? Initial and final, how to identify? Right. Initial means what? When according to T is equal to 0. What is the stage? What is the stage of the system? And final at T is equal to infinity. This is a final value. So behavior of the system we have to analyze. That comes under the initial and as well as the final condition. Second one, derive the transient response of RLC series circuit. RLC. So before we discuss only RL, it is single order equation. Here RLC is there. So we see this figure, right? So RLC, transient response. This is a second order equation. If you write, if apply the KVL across this one, apply KVL across this one, it is a second order equation. Second order equation, right? So by using a second order equation, quadratic equation, we will have three different types of conditions. That is b square minus 4ac by 2a less than, greater than, or equal to, right? So like that we have to derive the relations in terms of current with respect of the time period. So derivation is also very important here, and as well as problem also he mentioned here, right? Forced value and as well as practical value you have to find with respect of initial and as well as the final conditions. Now in module 4, explain Laplace transform of step function, ramp function and impulse function, right? So this is a different one. This is a different one. Always we will write the relations in terms of time period t. Time period t. So some cases the system cannot be understood. The system stability cannot be understood. For that purpose, this time period can be converted into a S domain, that is frequency domain or angular frequency domain. So Laplace transformers is nothing but what? Where the time period can be converting into a frequency domain or S domain. In S domain, the system stable, unstable, critically stable, overstable, or we can identify very easily, right? So here we have three different types of inputs are there. Three different types of inputs are there in Laplace transformer. So first one is step function. First one is step. Step is nothing but what? That magnitude is always constant. Always constant. It is like this step function u of t. We'll say as a u of t. It is always constant. Okay. A system with respect of a step function, if we give, then the changes of the system may occur and we can control the system. And number 2 is ramp function. Ramp function is nothing but it is a linearly increasing one. Linearly increasing r of t, u of t. This is r of t. And third one is impulse function. Impulse function is nothing but what? It is a fixed one, del of t, and always is in a having constant magnitude. So three different types of inputs are there in Laplace transformers. Okay. So time to the frequency domain. Find the Laplace transformer of the function shown in figure. Okay. A waveform given here with respect to the time period t. Find the Laplace transformer. Apply the Laplace transformer of x of t becomes x of s, and here the intervals are right. So this is one type of a waveform. Okay. This is not continuous one, giving some discontinuous. Applying the limits of this one, first find the time period, time constants, then apply the Laplace to this one, then we can know the response of the system. The parallel RC circuit shown in figure energized by step voltage V of t 100 u of t. U of t is nothing but what? A step function. If the capacitors carry no charge initially, computes current supply by the source, current in each branch when switch is closed at t is equal to 0. Okay. Two parallel circuits are there. What are they? R and C. Resistance and as well as the capacitance. How? How much? V of t is equal to 100 u of t. So capacitors are not carrying any charge here, and to find the current supply by the source and current in each branch when switch is closed. Here switch is there. Okay. Here we have to find the two things, initial condition and as well as the final condition by applying the Laplace. Means t to the S domain. Two parallel circuits. Parallel circuits. When switch is closed, here, right? And the time period is R into C. R into C. Right? So this is parallel connection. Now, derive the relations for the response of RL circuit when step function is excited. When step function is excited, RL circuit. Yes. Same. In RLC it is a second order equation. What happens here? What will do? RLC, it is a second order equation. Okay. When roots are unstable, roots are distinct. So here critically damped, over damped and under damped. Three conditions we'll discuss in RLC series circuit. The second order equation I said earlier only. So with respect of the roots, how the plane, how the system, stable, unstable, critically stable, so we can identify by the relations. Okay, so this is comes as the transient analysis. It may be RL, it may be RC, it may be RLC, right? The system stability we can identify by using the Laplace transformers. Now, this is your last unit, module 5, where we'll discuss about the two-port parameters and as well as the resonance, right? So, Z and Y parameters. What do you mean by Z parameters? What do you mean by Y parameters? Here, see the students. Now, a two-port network can be input and output side, minus plus, V1, I1, V2, I2. So, V1, I1 are input, V2, I2 are output. Two are dependent variables, two are independent variables. These are very, very important here. This is a black box. Okay. So, the Z parameters, his other name is impedance parameters. So in impedance parameter, it have some two dependent values and two independent values. So what is the basic relation in this one? Let's see, right? So V1 is equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22. V1, V2 are dependent variables, whereas I1 and I2 are independent variables, So V1, V2 is equal to Z11, Z12, Z21, Z22 into I1 and as well as the I2. This is the basic notation, relations in between, and this is 2 by 2 matrix, right? So Z parameters in terms of voltage, so also known as open circuit parameters. What are open circuit parameters? Now coming to the Y parameters. Y parameters, other name is nothing but what are admittance parameters. So in admittance parameters, we will find the current. So Y11 V1 plus Y12 V2. I2 is equal to Y21 V1 plus Y22 V2. Then I1 I2 is equal to Y11 Y12 Y21 Y22 V1 and V2. These are short circuit parameters. Z parameters are open circuit, these are short circuit parameters, right? Write the differences between series resonance and parallel resonance. Yes, differences between series and as well as the parallel resonance. So resonance is depend upon the frequency. The condition is XL is equal to XC. It is a pure resistive circuit and consisting of unity power factor. So RLC in terms of series and parallel, the differences between series resonance and as well as parallel resonance, one magnifies the current, magnifies the voltage, minimum impedance, maximum impedance, unity power factor is always constant in series and as well as the parallel, and resonant frequency is different. Fr is equal to 1 by 2 pi root of LC, Fr is equal to 1 by under root of 1 by 2 pi minus L by C. It magnifies the voltage, magnifies the current. These are some of the differences between series and parallel. And the curve is V and as well as inverted V in terms of series and as well as the parallel. Half of the part is inductive and half of the part is capacitive. So the values in terms of inductive and capacitive, the graph can be drawn. So this is some of the differences between series and as well as the parallel resonance. Now define symmetry and reciprocity theorem. Okay, so in two-port network we have two different conditions that to be satisfied. Those are nothing but symmetry condition and as well as the reciprocity condition. Reciprocity condition is nothing but what? A combination of two ports. Combination of two ports. Port 1 and port 2 be linked. That was we are saying as a reciprocity. Whereas symmetry is exclusive the port 1 and as well as a port 2. Then that values are nothing but what? A symmetry values. For example, if you take a Z parameters, the symmetry condition is Z11 is equal to Z22. Z11 is equal to Z22. Whereas reciprocity condition is Z12 is equal to Z21. Z12 is equal to Z21. These values should be same. Then only it satisfies. Or Y parameters. Symmetry condition Y11 is equal to Y22 and reciprocity condition is Y12 is equal to Y21. Okay. So in two port when we are finding the things, this is also very important here. Symmetry condition and as well as the reciprocity condition. Now in module 5, the last questions are explain ABCD parameters and H parameters. So these are other two-port parameters. Those are ABCD and as well as the H parameters. Again, here also it consisting of two independent and as well as two dependent variables. And in that we have to find the unknown values ABCD, H11, H12, H21 and H22. But what is the importance of these transmission lines and as well as the H parameters? Okay, in electricity, the power is generating from one end and we are receiving it other end. So it is only a unidirectional, it is not a bidirectional. So here the transmission lines, when we are writing the relation, you have to keep a minus. Why? Because it is only the single direction, it is not a bidirectional, right? Here ABCD parameters are, the dependent values are V1 and as well as the I1, A, B, C and I2. This is the basic relations to find the ABCD parameter. Why this minus means it is in only one direction. In two port we have two directions, but here in transmission lines we have only one direction. To overcome that one, what we are doing, we are keeping one minus, right? Here the reciprocity condition and symmetry condition, A is equal to D is the symmetry condition and AD minus BC is equal to 1 is reciprocity condition. A is equal to D, AD minus BC is equal to 1, right? Reciprocity condition. So used in a transmission lines. Here, so here the circuits are open circuit and as well as the short circuit. In terms of when voltage is 0 and as well as current is 0, we will get these things, right? In the same way, when we are discussing about the H parameters, H parameters is basically used in electronics supply system or equivalent circuit diagram. So here we can have the H parameters, right? H11 and as well as H21, H22 and H12 are to find the parameters, right? So H parameters used in electronic components, and here also two independent and two dependent values will be there, the relations and as well as symmetry and reciprocity condition also there. Okay, now next one, B, define resonance, quality factor, bandwidth, resistivity condition to get the resonance. Okay, so resonance is nothing but what, it is a condition based one. Resonance is nothing but it's a frequency, one type of a frequency, right? Quality factor, quality is very important here. So it gives the value which is good, that value we are saying as a quality factor, and quality factor also depend upon the bandwidth and as well as the resonant frequency, right? So what is the meaning of bandwidth then? Bandwidth is nothing but what, it is the differences between two frequencies, f2 minus f1, or upper cutoff frequency minus lower cutoff frequency is nothing but what, bandwidth. Next, selectivity. Signals can be selected within the range of the frequency, so that is done by the selectivity without any disturbance or without any noise. So how to check means by using this selectivity, right? And what is the condition to get the resonance is, that is XL is equal to XC. This is the condition to get a resonance, and from that one we will get a resonant frequency, that is 1 by 2 pi Fc, 1 by 2 pi Fc. The last one, convert Z parameters to Y parameters, right? So according to our convenience, if it is a voltage, convert into a current, or current convert into a voltage, like that Z parameters can be converted into Y parameters, or Y parameters converted into a Z parameters, or Z to ABCD, or ABC to H, H to Y, Y to Z, like that according to our requirement we can convert the parameters. So here convert Z parameters into Y parameters means voltage has to be converted into a current, right? Here V1, V2 is in terms of I1 and as well as the I2, that is Z11 in terms of Y11, Z21 is equal to Y21, and Z22 is equal to Y22. So these values, Z values are all converting into a Y parameters. So what is the importance here? Okay, also very important here, right? So conversion of one parameter to other parameter, a derivation, or it may be a problem you will get. So practice as many as number of things, right? So here this is Z parameters. This is Z parameters notation or a relation. I want a Y parameters with I1, I2. Okay, then I1, I2, V1, V2 by Z11, Z12, Z. Take determinant value and convert this Z11, Z12, Z21 in terms of Y11, Y12, Y21 and as well as the Y22, vice versa. We'll get a, right. So Z parameters in terms of Y parameters, then I1 is equal to V1, V2 by Z12, Z22 by delta Z, where delta is the determinant value in terms of Z11, Z12, Z21 and as well as the Z22. So same I1 and as well as the I2. So this is Y parameters. Previous it is Z parameters. Now, so last what happens means here Y11 is equal to Z22 into delta Z, and Y12 is equal to Z12 by delta Z, and Y21 is equal to minus Z21 by delta Z, and Y22 is equal to Z11 by delta Z. Just here Y11 becomes here 2 to 2. Here 2 to b becomes here z11, and remaining this y12 and y21 both are same. Both are same. So z to the y parameters or y to the z parameters, according to our requirement, we can convert one to other parameters. So this is the total model paper of network theory. So try to practice as many as number of problems and get good marks in your subject.